continue with the multicast, and we'll pick the first protocol, which is the IGMP, right? We'll do packet captures and we'll look into how it actually works. Before that, a bit of theory. Why do we need IGMP, right? IGMP basically stands for your Internet Group Management Protocol, and we are in this particular, we are starting with the version 1. Now, why is IGMP needed? Reason is because, let's say you have the host here, right? I have 2 hosts. These hosts should have a way to announce to the router that they want to receive multicast traffic for a particular group, and the group could be anything. It could be something like, say this guy is interested in 239.1.1.1. So there should be a way for him to communicate to the upstream router, right, saying that, please send the multicast traffic destined to this group to me, right? That's the, what is that? That's the report message. So there are 2 messages. One is your report message and the other one is your query message, right? We'll see this in the packet captures, right? So the message which goes from the host towards the router is the report message, which we just now saw, this one. But there is one more message called as the query message. What is the use of this? This is kind of like periodically sent by my router downstream, right? Just to check the health of the host, just to check if the host really is still, do the host still want the traffic, right? Because what if the host no longer wants the traffic, right? So this is a query message which is sent downstream towards the host, and when the host sees this message, it will again go back to sending the report message in the upward direction, in this direction, right? So when the host receives the message, it's going to say, okay, you're sending me a query and I want to respond to your query with the report message. So that works in a very cyclic fashion, right? Query comes from up to down, report goes from down to up, right? So this continues until I want the traffic. Until I want traffic for this particular group, the hosts are going to continue behaving in this way. Cool, awesome. Let me just go down to let me probably clean this up a bit. Let's go down to our configuration here. Let me just grab this once again so that we don't have to go back and forth. And here you go. Awesome. So we have, like I said, R1, H1 and H2. And what we'll do is I have captures enabled as well. This is on my router and this is my H1. Let's go about configuring these guys now, right? So when I talk about configuring, it's pretty simple again. Let's see. Okay, my console is working. So let's go enable, let's go to the global mode. Let's enable multicast routing because that's needed. Awesome. Next, let's go into the interface, Ethernet 0/0. That's the interface where I want, what do I want? I want IP IGMP version 1. By default, the version is 2. So I have to enable version 1. IP PIM, I have to enable a PIM, basically PIM is the multicast routing, which we'll look into later. But we need PIM because PIM is needed for multicast routing between routers, and it is also required for the router to process IGMP traffic. So there you go, I've enabled PIM sparse mode. Could be dense mode, sparse mode, anything, but for now I've enabled sparse mode. Sweet. Then let's quickly go and check what has happened. Show IP IGMP Ethernet 0/0. I think it's interface, sorry. There you go. So IGMP is enabled on the interface. IGMP query interval is set to 60 seconds. That periodic query which I was talking about, 60 seconds, every 60 seconds. And let's see what has happened from a capture perspective, right? There you go. I can see a membership, or let me filter this based on IGMP. There you go. I'm getting the query messages. You can see the query message is sent to 224.0.0.1, right? This is what I was trying to explain earlier, right? So it is sent to a particular group. The query messages, when it is sent by the router, upstream router, it will be sending it to a particular group, which is the 224.0.0.1. This has nothing to do with my group which I'm really interested in listening to. This is the universal group to which your routers will basically send the query messages, right? There you go. So I'm receiving the query message. Right now there is what is this? Yeah. So am I observing this on the same one? Give me a second. All right. So that's fine. I think I have a hub here. So as a result, I'm basically getting the same stream, though I'm capturing it over here as well as here, right? It's a hub here. So that's fine. So we have just what we have done till now. We have enabled it on my R1. Let's pump the gas a bit and go to the next, where we are basically going to enable, or we will go to the east of the host, right, which we have here. I'm using my router itself as the host, just an FII, Ethernet 0/0. What I do is IP IGMP version 1, and let's do IP IGMP join group, right? And let's say we want to join to 239.1.1.1. There you go. Let's see what's happening now. There you go. I can see a report coming in from 101. Forget about the 224.0.1.40 that is related to auto RP and stuff, which we'll discuss later. Look at this particular report which I have highlighted, right? So this is a report message, IGMP report message going from the host 1 towards the 239.1.1.1. That's the destination IP, which is basically the destination destination multicast group which I am interested in listening to, right? I'm basically telling my router, hey, I'm interested in listening to 239.1.1.1, send it to me, right? Let's do the same thing on the other guy as well. Let's just pick this one. Let's go here. Let's go enable configure Ethernet 0/0, and let's enable it here. And we should start seeing the reports probably from here as well. There you go. So we can see the reports from there as well. Not a very good way to capture, I guess. I should have replaced this with this hub with, say, a switch. But anyway, I have an hub and we are getting to see everything here. So you can see the second report message has come, and that's also going in for the same group address. So till now we have seen the two things which we discussed. We have seen the query message here coming in from the router downstream towards the host, and we have seen the membership report going from the host towards the router, right? Let's enable debugs to see some cool stuff again. Probably we might get to see the whole workflow, right? I really like debugs for that. So if we do debug IP IGMP, let's do that on this guy as well as this guy, right? So there you go. I can already see some debugs. You can see this guy, the R1 is sending its periodic query messages, right? And it is also receiving let me just drag this a bit to the left. Yeah, R1 is receiving the report as well, V1 report from, forget about the 221, let's concentrate on the 102. There you go. It is receiving the report from 102, right? It is also receiving the report from 101, right? So from both the two hosts, it is receiving everything. Now let's say I'm no longer interested. Let's say my hosts are no longer interested in what? Receiving the multicast traffic for that particular group. So the only thing which I'll have to do is I'll have to pick this guy and run a no command, right? So let's do that. So let's do no. Let's do it on both the guys, right? So when we did this, and you can see the log which you see here, IGMP delete group 239.1.1.1. So my host kind of removed this particular group from its database. I can go to my R1 as well. This guy also is kind of like receiving the messages, and it is trying to update its database, but mainly we'll see show IP IGMP groups 239.1.1.1, right? Right now it still seems to be forwarding traffic because there is a timer here, right? So the timer which is going to expire in like 2 minutes 24 seconds, right? So once this timer expires, right, this particular entry will be removed, right? So IGMP version 1 works that way, right? So IGMP version 1 is a very simple protocol with only two different packets, right? One of the downsides of IGMP version 1 is that the router will keep forwarding multicast traffic even when there are no hosts interested in traffic, right? Until this timer expires. Right now, it will still continue, right? Until, so I'll pause the video for another 1 minute 38 seconds, and we'll come back and see that entry should have gone. There you go. As we predicted, you can see the last log has come in, which is telling delete this entry from the group, right? And you can see now it no longer, is forwarding traffic for this particular group because you don't have any host listening to it. But it had to wait for the timer to expire, right? And it did not happen immediately. So that's something which is getting fixed in IGMP version 2. So give me a second, let me clean up this and we'll come back and we'll talk about IGMP version 2. Alright, so in IGMP v2, the shortcomings of IGMP v1 are fixed, right? What I mean by that is, in IGMP v2, the host, in v1 what happened was when the host, will just stop listening to the multicast groups, but they'll never report it back to the, router, right? They'll just stop, that's it. But in IGMP version 2, what has happened is we have something called as a leave group message, right? So you have this leave group messages. So when a host no longer wants to listen to a multicast group address, they will report it back to the router that it has stopped listening, right? Apart from that, there are a few other stuff as well, like for example, the router will be able to send a message which is the query message which we talked about, right? We talked about the query message in v1, right? But now the router will be able to send query message which is specific to a group as well, right? In this case, say 239.1.1.1, it can send a more specific query message. In v1, it was not specific. It was like to the whole multicast, addresses possible. But here you can send query messages which are specific to a group address, right? And there are a couple of other stuff, but I think those it will be better if I explain you while we kind of do the lab, right? So let's get to it. So let's go back to my topology here. Let's do the regular stuff, which is R1. Let's go to R1, configure, same thing, IP multicast routing. I cleared out all the configuration, that's why I'm doing it again. But if you already have it, then don't have to. Ethernet 0/0, IP PIM sparse mode, right? Till now it's pretty much same as the previous one. If you want, you can do IP IGMP version 2, but by default itself it is version 2, right? And let's see, what is this? Show IP IGMP interface Ethernet 0/0. There you go, it is enabled. You can see the version is 2, right? And it is enabled here. You can see the query interval is 60 seconds, and the IGMP querying router is 192.168.1.1, right? Which is R1, this system. What else? So I think that's pretty good. Let's go and probably also do debug on IP IGMP. Enable debugs on this guy as well, and on this guy. Okay, so we've got some debugs. Just like IGMP version 1, we should have started seeing the query messages. Let's do IGMP here, and you can see the query messages here, right? Very same as the previous one, right? You can see the query message is going to 224.0.0.1. Now let's spice it up a bit. Let's go to the host one. Let's go to the interface. Which interface? Ethernet 0/0, and let's make our host join IP IGMP. By default it is version 2, so it's pretty good. So IP IGMP join group 239.1.1.1, right? So when I do this, what should I see? I should basically see some logs coming in now. See, there you go, it has inserted. It is sending the v2 report, and here on the IGMP I should have seen a membership coming in. There you go, membership report has come in from host 1, and you can see it is pretty much same as what we did till now. It was same as version 1, right? We covered this before. So till now everything is fine, works exactly as version 1. But when we add the second host, right, when we add the second host, which is H2, this is where it gets very interesting, right? So observe this, very interesting. So now what we'll do is we'll go to interface Ethernet 0/0 and we'll say the same thing what we did here, right? When we do this, it's gonna get really fun. So observe this. So let me hit the enter. Let's look at the logs on R1, right? The R1 has received the report from, the host 2, right? It has received the report from host 1, host 2, everything is good. No, it's received it from, let's see from where it has received. It's not from host 2, my bad. So it's received it from, yeah, it's received here. That's fine. So let's go and check the logs here, right? So on H1, you can see there is a very interesting log which said cancel report for 239.1.1.1, right? This is very interesting. We did not see this in version 1, right? So what has happened is in the background, both of the hosts have received the query message. Look here, we have received the query message on H1, we have received the query message on H2, right? That's straightforward. But only one of the hosts has sent back the report. H2 has sent the membership report, but H1 has not sent the membership report. It is, you can see a log here saying cancel report, right? So that's one of the, let's say differences between IGMP v1 and v2, right? So in the background, what happens is the H1, right, receives the query, right, and it sets a report delay time of, in this case, what, 6.2 seconds, right? It's randomly selected. You can see here the H1 has received the report and it has set a report delay time of 6.2 seconds. Let's see how much this guy set. This guy set 4.8 seconds. It's random. Because this guy's delay time is shorter, he won kind of like, let's say he won the competition and he went and reported, or he was, wait a minute. So who sent the report? Okay, this was for the previous one, right? Here. So previous one, this is the new one, sorry. So the previous one, you can see this guy was allotted 0.8 seconds, whereas, this guy was, I think, allotted 1.6 seconds. As a result, H2 won the, let's say, election or whatever it is, competition, and he was allowed to send the report back, right? That's why, on your R1, you'll basically be getting only one report, right? But it will continuously change. Look here in the second case, I think this guy was given 6.2 seconds and okay, so here also you see a cancel report, but this time, right, he sent the report, right? And here also you can see, H1 is sending the report. So it's like, why we do this, right? Why we do this is because in a big network, you might have a lot of clients and you don't want to like waste the bandwidth in the network by sending a lot of reports, right? Membership reports. So that's why they have come up with the optimal way wherein, one of the hosts will reply back with the, membership report, right? So if H2 is sending the membership report, right, H1 will be quiet, right? So H1 will receive a message saying that, H2 sent the report, so I should not send it. So that's why it's going to cancel it, right? So if you observe this query logs, you'll understand that, right? You will basically get to see whenever you see this cancel message, right? Just try to read the messages just before that. You'll get to see here, it is telling it has received the V2 report from H2. So H1 has received the message that H2 has sent the report, so I'm going to cancel mine. That's the logic here, right? Pretty simple. So that's interesting. And I'm not sure if I can show you the, let's look at the query message. The query message here will be interesting. There's a, let's look at the query message. Yeah, I think this is a query message. Yeah, in the query message, right, when R1 is sending the query message, you can see a new field called MRT field here. This MRT field, it is mentioning, you can see 10 seconds being mentioned here, right? So this is basically completely related to what we are discussing, right? So the MRT time is that maximum amount of time our hosts have to respond to a membership query, right? So our H1 and H2 have 10 seconds to respond to the query. If it doesn't get a response, then R1 will assume that, okay, my hosts no longer require, or no longer listening to the multicast group, right? So this is the time which decides that, in the query message, you can see 10 seconds being sent out. When the timer expires, the host will, it will no longer send the multicast package now, right? And this whole feature, right, whatever I talked about here, this whole feature about cancelling the report and only one guy is sending the report, this is basically called as report suppression, and that's there in your version 2, right? The last part is the leave mechanism, which I want to show you here. What we'll do is have we enabled this on both the guys? Yeah, okay. So we'll go and do something like this. Right, so let's go to my let's do this on probably H2. Let's go to H2. Yeah. So let's say I'll do no IP IGMP join group. So I'm doing a no, which means I want to leave the group. So let's see what happens. Right. So I'm sending a leave, and the R1 will receive it. Right. So it is so it's updating, and we should see. Now, this is also very interesting. So whenever it receives a leave, let's actually go and do it for both the guys. We can do it on this guy as well. Let's do it on H1 as well. So let's do the leave on H1 too. Right? So there are two things. You can see the difference of logs which you are seeing, right, on H2 and H1. Now, what happens is in the background, this is very interesting. So when the host try to leave the group, right, in response to that, our R1 will send a query message, right? So whenever R1 receives a leave message, right, so it is receiving a leave message, right? Whenever it receives a leave message, it will send a query message, in response to that, just to check if there are any more hosts listening, to the group, because there could be, right? In this case, if H2 is leaving, we still have H1, right, who wants to listen to the group. So that's how it works. So whenever it receives a leave message, it will reply back with a query message, just to make sure that there are no more hosts which are listening to that group, right? So that's pretty good. Now, when it is the final host, right, now when the final host leaves, in our case, when the H1 also leaves, in our case, I think removed H2 first and then we removed H1. So when the final host leaves, right, it will delete the entry from the table. You can see here it deleted, right, because it is no longer getting any reports, right, for any of the from any of the hosts. As a result, it will delete off. So this happened quite quickly than our IGMP version 1, didn't it? Right. So now if I see my output of the command, if I see something like show IP IGMP groups 239.1.1.1, there you go, right? It is not forwarding anymore. So these are a couple of advancements which were done when compared to IGMP version 1. Just to recap, the first good thing is the first good thing is about the report suppression, right? Not all the membership reports will be sent upstream. Only one of the membership report will be sent, so that you don't clog your network with all these IGMP messages. So that was kind of an optimal way to go about it. The second thing is when the hosts are leaving, right, they will send a leave message, right? We could probably see the leave message as well. Maybe if we can spot it here. Give it a second. Right, there you go. I've highlighted the leave message here. So when the hosts are basically leaving the group, they will send a leave group message, so that your router doesn't have to wait for the timer to expire and then stop forwarding, right? So So as soon as this guy sends a leave message, your you can see the series right here. As soon as this guy sends a leave message, you can see your router replying back with a query message, right? Querying that, just to double check that if no one else is listening. So if it is not, you can see there is no more reports, right? No more reports at least going in from any of our 239.1.1. There is no more reports going from there. As a result, it will remove the entry from the table and it will no longer forward the packets. So that was IGMP version 2. Alright, we are going to the last version of IGMP version 3. The main highlight of IGMP version 3 is that let's take a scenario, right? Let's say our router is here and we have our clients connecting down, right? We have your various clients here, right? 1, probably 2, 3 and so on. You have clients. Now we have a legitimate multicast source, right? The video server which we were talking earlier. Legitimate source. This is sending the traffic and this guy is sending it down. Everything is working fine. What if there is an attacker sitting here, right? And he is also streaming data to the same multicast destination, right? So let's say the destination is something like 239.1.1.1. So both of them are sending. So this guy is the attacker. So both of them are basically sending the traffic, right? So, and that traffic also gets forwarded down and my clients basically end up getting it. So this is really not good, right? I should literally be allowed to, or I should actually have only the healthy or only the video server traffic, but then I'm also getting the traffic from the attacker, right? So that's something which got fixed in IGMP version 3, where you are allowing now hosts, right, which are sitting here, the hosts which are there here, the hosts are allowed to join multicast groups for a specific source address, right? The source address check is done. So in this case, let's say the traffic is coming from 1.1.1. So we'll basically be making sure that these clients basically get the multicast data which is directed, or multicast traffic which is directed towards this group, but from this particular source and not from some attacker over here, right? That's what we are trying to solve. Let's go back to the topo here and let's play around with it, right? So pretty straightforward. Let me just grab this. Okay, so we have R1, R2, right? Both of them are connected by 192.168.1.0 subnet. This is 1.1, I think, and this one is 1.101, I guess. Yeah, it's 101. Let's clear the screen a bit. Looks little. Let's clear the screen here as well. Maybe let's get rid of this too. Okay, looks good now. So we are on R1. What we'll do first is, let's do the same stuff, where we will first go and enable IP multicast routing. Let's go to interface Ethernet 0/0. Let's what do we do next? Let's do IP PIM sparse mode. We're enabling sparse mode, right? Then IP IGMP version, this time we have to make it version 3. And as usual, when you do that, you should start seeing the, let's do IGMP here. There you go. You can see IGMP query. You should start seeing the query messages, right? So you can see IGMP general query here, right? Pretty straightforward. This is what we have done till now. This is same across V1, V2, V3. Next we'll go to H1, right? And we'll say here as well, let's probably, give me a second, IP IGMP version, sorry, I'm doing it wrong place. Interface Ethernet 0/0, IP IGMP version 3, and what we'll do next, I'll say IP IGMP, I want to join the group 239.1.1.1. Let's hit the question mark here, and you can see there is a option to select source. So I'm going to select source, and let's put a address called 1.1.1.1, right? So this is what IGMP version 3 brings to the table, right? It is allowing me to select the source from where I want the traffic, right? And once I do that, probably I should have enabled debugs. I'm not sure, probably let's do that here. Yeah. Actually, let me do this again because I really want to see those debugs. So let's disable this and do this again. I should have enabled the debugs before enabling this, but anyway. So let's pick this guy. Let's say no, right? So that's deleting it. Let's now go and enable it again, right? So you can see a bunch of things happening. It is creating a source 1.1.1, right? It's inserting 239.1.1.1. It's creating the source 1.1.1. So everything is now based on the source, right? The source is given importance. We are not going to accept traffic coming in from some attacker, right? It's going to build a v3 report. v3 because it is IGMP v3. So it's building the report, right? The membership report message, adding the group record, right? And it will send an unsolicited v3 report, right, towards my R1, right? All of this is pretty straightforward. This guy would have received all of that as well, right? So we'll see the messages. So the host basically sends 2 membership reports, right? There will be 2 membership reports being sent out, right? And that's what we'll see here if we are lucky, right? So let's see. You can see here the first membership report is this one, right? The first membership report or message includes the multicast group address and the source address that we want to receive, right? So there you go. So we have sorry, not this one. This is the 224, right? Not that one. Let's pick the right one. The 224 one, just ignore that. That's only coming from the auto RP. So yeah, this is what I was talking about. The first membership report message is having the 1.1.1, which is the source address, and it's also having the multicast address to which I want to receive messages. The second report message is very interesting. Let's click on this. The second report message, this is the second report message. And what is this message? Let's go inside the IGMP and let's see, we should see something cool here. Where is that? There should be a record type. Okay, so I think not that one again. Let me just pick the right one. Yeah, this one. Okay, cool. This makes sense, I guess. Yeah, this one. So this is the second membership report, because this is just one single wire where I'm capturing everything. I'm basically getting everything over here, but not to worry. This is the second one, and the first one I already showed you, right? The second one, the second membership report, you can see there is a very interesting piece here. The second membership report includes what we call as a mode, right? The mode is included here. And the mode, there are 2 types of modes. One is the include mode and one more is the exclude mode. The include mode basically includes a list of source addresses that we accept the multicast traffic from, right? So that is why you have the source address here. I can also have exclude mode also, right, which is another type of mode where I can again mention the list of source addresses from where I don't want the multicast traffic from, right, to refuse to accept the multicast traffic. So I can do either of them, right? So this is the include mode where which I'm using right now. Yeah, so just look at the pattern. You still have the query message, right, which is coming in. Forget about this one, and you can see the membership reports, right? There will be always 2 membership reports which are basically going to be sent, right? The first membership report is basically going to include only the if you see here at the top, I think that's very I think this one is better to watch. Give me a second, let me try to order them. Yeah, so I kind of managed to kind of put it in order to at least view it. So you can see the first type of membership reports. These are the ones which I've highlighted here, right? You'll basically see something like this. This will be the first membership report. If you see under each of them, you'll basically have the group address, 239.1.1.1 and the source mentioned. And the second type of membership report which will be sent is this one, where it is going to mention the mode, right? In this case, it is mode is include, right? And which is basically telling I am allowed or I want to receive the multicast traffic for this group, but from this particular source, and the mode is include. All right. So next is let me just get rid of this. The last part which I want to show you here is what happens when we leave the group. So let's go and do that. So let's go to R1. Let's go to R1 and let's say I want to leave the group, right? I mean, the meaning of leaving the group is I no longer want to receive traffic for that group, right? So H1 will, which is the host, it will send a membership report to indicate that it doesn't want to receive the multicast traffic, for this source anymore, right? You can see that it is sending a report that it doesn't want to receive the traffic, right? And H1 will receive that as well, and look at that, it is deleting it, right? So we could probably see that here as well. So the membership report has come in over here. Probably let's look at the last membership report, this one, right? So it's basically telling that you can see the block old sources here. So it says that basically it doesn't want to receive traffic anymore, right? And that's why that's the last membership report you got. And as soon as you get the membership report, your router will reply back with a query saying that is there anyone else who wants to listen to this group? And once it finds that there is no one, right, it will go and delete it. You can see here MRT delete. It's basically deleting it from the from the database itself, and that way it will no longer forward traffic, multicast traffic along this particular port. So that's mainly it, guys. All the various types of IGMP we just looked at 1, 2 and 3. There are some advancements done in each version, right? Basically in version 1 it was plain and simple. You just had membership report and membership query messages. But then as we went with version 2, what they did was they kind of added the leave mechanism, the leave group mechanism, right? And they also added the MRT fields, right, using which you can suppress, right, your report messages. We talked about that, report suppression. We did a demo with that. And in IGMP v3 we kind of made it more secure by preventing some attackers from sending multicast streams to the host by taking decisions based on the source address. So now the host can join a multicast group for a specific host source address. Hope you guys liked it. Thanks a lot for watching.